Hello and welcome to Technology Update. On today's show, we learn about the technology that keeps the Moscow Metro rolling. New surveying and modelling techniques make waves in the oil industry. And we take a peek through the innovation looking glass in this month's Focal Point. But first, today's technology means that robotic helpers are no longer yesterday's science fiction, making many walks of life both easier and safer. And this is especially true of this next robotic dream team.
Brains Over Brawn.
The world's a dangerous place, so robots are frequently used to scout out areas and perform tasks too hazardous for humans. In addition to the classic humanoid, designers often turn to nature for inspiration. This has resulted in myriad weird and wonderful creations. But even if we have to go in harm's way, a robot will put us back together again if things go wrong. However, building a machine capable of such precision in highly demanding environments still requires a human touch. Set up in St. Petersburg 23 years ago, the Acont employs around 1,000 people. It's forged a name for itself as a top supplier of high-tech inspection and maintenance robots for the nuclear and oil and gas industries. The company has shipped around 20,000 pieces of equipment to 23 countries around the world. But the applications of its products aren't just limited to Earth. The Acont has even manufactured components for spaceship docking mechanisms and electromechanical fuel valves for launch vehicles. We caught up with the company's deputy director to find out more.
The company's mission is to ensure complete control over manufacturing processes and high-tech product development. We have over 300 engineers and specialists who, from project scope, document drafting, and process development and implementation, create the technology to make the product, which is then manufactured using the equipment located on our site here. It's then assembled, tested, and delivered to client.
One of the secrets behind the company's cosmic success is its expansive production facilities, which occupy around 5,000 square meters and continue to grow. Many of the Acont's products play a vital part in the safe operation of energy production facilities, so failure is simply not an option. So to ensure the quality of its equipment remains top-notch, the company has hand-picked the best tooling machines from suppliers around the world. While all this high-end machinery may cost a pretty penny, the full-cycle production means that the company can design and build turnkey products at the drop of a hat. This ability has not only earned the company orders from the likes of General Electric, but also resulted in a rather motley crew. Since 2005, for the nuclear, oil and gas and space industries, the Acont has designed and assembled an entire family of robots, and it continues to grow. The first generation includes a pipe inspection robot, which uses ultrasound to check for defects, corrosion, and other irregularities in high-pressure gas pipelines. This snake-like welding robot is designed for carrying out repairs inside nuclear reactors. The machine is radiation-proof, can slither through a gap the size of a matchbox, and slinks along the walls magnetically. The company's remote inspection robot uses laser holographic technology to check the integrity of reactor seals to prevent any coolant leakage. Finally, one of the latest additions to the family checks the alignment of water pipes deep inside a nuclear reactor. If any repairs are required, a nifty mini robot can be deployed to attach a metal brace to the pipe. But even this high-tech family has relatively humble beginnings.
We started off with special TV cameras capable of working in high radiation levels and underwater. They're used to control the technical processes associated with refueling nuclear reactors and the most important equipment of a nuclear power plant.
Ordinary glass becomes tinted in a matter of seconds when exposed to radiation, so the Acont uses custom-made radiation-proof glass in its lenses, which are then assembled on-site. For the camera itself, the company has gone back to basics using a black and white video camera tube, avoiding the use of complex chipsets and placing as much of the electronics as possible in a remote block well out of harm's way, while the red LEDs take advantage of the video tube's sensitivity sweet spot in the light spectrum. They're currently working on a colour version that works by flickering between red, green and blue and combining them to create a colour image. But whatever the product, testing is key.
We test every component separately, as well as the parts of the final product, and then the final product itself. We cooperate with a number of facilities that allow us to test them under intense gamma-ray conditions. Some products undergo field testing at our clients' facilities.
Diacont also has its own testing facilities, and we arrived just in time to see one of their latest gizmos strut its stuff. Gas compressor stations contain a whole tangle of pipes that can't be checked by the unfortunately named pigs or pipe inspection gauges. Diacont's explosion-proof robot, on the other hand, can move along even the most twisted of pipelines, thanks to its studded tracks that can push against the inside of the pipe with a force of 180 kilograms. While its electromagnetic acoustic transducer, or EMAT, doesn't even require direct contact with the pipe. It detects microscopic defects and corrosion that could lead to massive problems down the line. It has a number of cameras for visual inspection and is in service in countries around the world. Compressor stations are frequently located in far-flung places inaccessible by standard transport means, so the company has converted a 6-wheel drive Kamaz that can traverse even the most rugged terrain with ease and transmit all this data back to base with its satellite uplink.
The technology being made today requires super precise components with impressive capabilities, but in limited quantities. Maximum a couple of hundred a year. The company plans to switch to mass production, which will mean different technologies and approaches, which is why we're building another factory.
Diacont's attention to detail has secured it a place among the elite robotics companies of the world. It continues to strive to refine its designs and solve ever more complicated tasks. With its new production facilities just around the corner, I'm sure we'll be seeing much more of its high-tech helpers soon. So next time you turn on the TV or put the kettle on, spare a thought for the robotic team that help keep the energy workers safe and our homes warm. The Moscow Metro is the third largest in the world. It's the heart of the city, transporting around 9 million people every day in its web of tunnels. Needless to say, all this traffic takes its toll.
What's up in the lab?
Every morning I join the throngs of people commuting to work in the hustle and bustle of the Moscow Metro. And Sokolniki here on the Red Line was one of the first stations built. Opened in 1935 as a showpiece for the Soviet government, the beauty of the metro is known the world over. Almost 80 years later, there are still ambitious plans for its expansion, so the need to ensure the safety of both old lines and new has never been greater. Metro inspection technology has come a long way since the days of hand-push trolleys, culminating in the Synergia 1, the Moscow Metro's latest weapon in the never-ending battle against wear and tear. The train can check the track, power and tunnels at the same speed as normal passenger trains, meaning that inspections can be carried out during the day and repairs at night. But to deal with the longer peak times and growing passenger traffic, the Synergia needs a lot more than just speed. The Synergia combines the functions of 3 old diagnostic trains, meaning that a stretch of track that used to take 6 months to cover now only takes 1. It requires half the number of staff to operate and much less power to run. Now that's what I call a synergy effect. The Synergia 1 is bursting at the rivets with sensors and diagnostic equipment capable of checking all the vital statistics of the track and tunnel. The defectoscope attached to the rear bogie uses ultrasound to check for signs of wear and tear. The track measurement system at the front verifies the distance between the rails and their respective height. The structure gauge near the roof comprises 4 lidars, which use lasers to measure the clearance in the tunnel. Synergia 1 also has visual inspection cameras underneath, at the side and on top. And the whole carriage is weighed down with a concrete slab to test the rails at 10 tons over their normal load. The masses of information generated by the group of sensors is all recorded and processed in real time by powerful computers on board. It's closely monitored by the eagle-eyed team for any blips and glitches. In the absence of GLONASS signal deep below the capital, any problem areas are linked to a series of unique tags running along the rails. The hypnotic video footage can also be rewound and scrutinized by specialists at the end of the run. And that's not all.
In addition to the existing 2 systems that we used, that's the track monitoring system and the fault detection system, we also introduced some new ones, like a 3D laser gauging system. a high-speed video monitoring of tracks and joints. And we also have a third monitoring system that checks on the condition of the power rail, checking on its temperature and the visual data. Systems like that have never been used before.
With the Moscow Metro set to expand by almost 150 kilometers by 2020, I'm sure the Synergia 1 will have its work cut out. The company behind the Synergia is Tverma. Starting with defectoscopes 25 years ago, their equipment now accounts for almost 3/4 of Russian Railways' diagnostic fleet. They have more than 250 trains and over 2,500 manual diagnostic tools in operation worldwide. The company had only 3 members of staff when it was launched. It now employs over 300 people, including marketing, production and engineering specialists, while its team of experienced programmers write all their software in-house. The company is actively branching out into new markets, including China, Germany and the CIS, so you certainly won't find any of the team resting on their laurels.
Of course, we will definitely try to apply this experience to other Russian metro systems. And there is a demand for such trains across Russia. As far as I know, the Moscow Metro plans to build another Synergia, which we believe will be even better than this one.
The Sprinter is the company's flagship mainline model. It's definitely no slow coach, as it's currently only one of a few diagnostic trains in the world capable of checking every millimetre of track at up to 140 kilometers an hour. This means it can fit in with existing timetables and eliminate disruption to services. Their latest defectoscope has overcome traditional problems with the diffusion of ultrasound in metal, which until now has limited speeds. The defectoscope releases a thin film of water onto the rails to improve the readings.
This has never before been done on a passenger car that's equipped with a bolsterless bogie. This is the first time that a non-contact centering system has ever been installed on the main bogie. We're also making use of a brand new detection system, as well as various new software solutions. They allow us to implement a lot of new monitoring technology, which in turn enables higher monitoring speeds.
The high-speed Sapsan was only introduced 4 years ago, but construction has already started on a new 400 km/h line. Whatever the future of rail transport, I'm sure Tverma will play a key role in keeping plans on track and getting me to work. That's just the end of the first half, so don't move. See you after the break. Welcome back. Before we continue with the rest of the show, let's see what else has been happening this month.
News Bites.
Russian Internet Week took place towards the end of last month, attracting around 15,000 visitors. Arguably the most important event in the RuNet calendar, it gives .ru giants and newcomers alike the chance to discuss topics from advertising, social media and digital marketing to big data, cybersecurity and online regulation. And talking about .ru giants, Russia's most popular search engine Yandex continued with its global expansion by rolling out its popular map service worldwide. The press conference was fittingly held in the Moscow Planetarium. Yandex had to translate over 7 million street, town and city names from 237 countries, and the maps will be updated every 3 months. The company had to develop the technology to process the vast amount of cartographic data 100 times faster than the old service.
Our online rendering system processes user requests to model the image they need and does it very quickly. In order to develop this technology, we had to rethink all the mathematical algorithms. We had to start from scratch, and this was a real breakthrough.
The largest of 4 reactors arrived at the Achinsky oil refinery on the 28th of October. The 1,450-ton giant was transported 203 kilometers by a 384-wheel platform at a nippy 2 kilometers an hour. The feat has made it into the Russian Guinness Book of Records as the heaviest cargo transported on public roads. The L'Oréal UNESCO for Women in Science Awards ceremony was held on the 12th of November. It's supported by the Russian Academy of Sciences and is designed to raise the profile of female scientists. Over 500 applications were made for one of the 10 fellowships. Each winner walked away with a 400 ruble grant because they're worth it. Oil and gas are big business. They're the backbone of the Russian economy and a lifeline during the winter months. Fortunately, the world still has oil aplenty, but the days of cheap so-called easy oil are all but over.
Core Tech.
Some of the world's oldest oil fields have been pumping for over a century. Well engineers are always finding inspired ways of boosting and maintaining output, but there are limits. Eventually, we're going to have to find new deposits. Russia has 27.7 billion tons of oil, making up 10% of the world's supply, the vast majority of which lies in Western Siberia. Around 60% of the total is considered difficult to extract, so the future of the oil industry relies on finding new sources, many of which are out at sea. The huge pressure to find oil rests on the shoulders of geologists like these chaps. They examine the terrain features, rocks and soil types to find the right conditions for oil traps. But unfortunately for these guys, traditional surveying techniques no longer come up to scratch. The Tomsk region is rich in natural resources, particularly oil and natural gas. But when faced with depleting oil fields and strict export targets in the mid-80s, the region had to come up with new ways of squeezing the last drops of oil out of existing fields. The Tomsk Polytechnic University has an impressive archive of core samples taken from the region's wells. Core analysis on the porosity and permeability of the rock can be used to determine the reservoir storage capacity and the ability of fluids to flow through the rock. These measurements are used to determine the recoverable reserves and the rates at which they can be extracted. The process itself involves working out the chemical makeup of the rock. The sample is then heated and compressed in a chamber to simulate the conditions under which it will be drilled. And the results of these tests help determine the best drilling method when it comes to the crunch. The extreme testing conditions are enough to crack even the hardest of rocks, so there's no room for error, as drilling for another sample is no small task. So trust the Skolkovo Innovation Center near Moscow to have the answer. Intravision has a way of conducting an infinite number of experiments while leaving the core sample completely intact. Digital rock physics involves creating a three-dimensional virtual model of the rock and simulating how it would behave under various physical processes.
Modern wells are very sensitive to methods of increasing extraction rates and development. So, sometimes you need to conduct hundreds or even thousands of experiments before drilling. Obviously, a real sample wouldn't withstand it, so that's where computer modeling comes in.
The precious core sample is placed in a computer tomography or CT scanner. The machine takes a series of 2D X-ray slices of it, which are then put together to create a full 3D virtual model, which contains all the pore spaces and mineral matrices that, along with its chemical makeup, determine its physical properties. While the resulting image wouldn't look out of place in a modern art gallery, the information it can provide is worth more than it would ever fetch at auction. The ability to test even the most fragile of samples to destruction until the heart's content provides invaluable information on the feasibility of launching production at new fields and boosting output at existing ones.
What matters most is the correct interpretation. You have to analyze the raw data the machines give you and translate it into the indicators geologists are used to, so that later they can choose the best drilling method.
Impressive though this technology may be, to take full advantage of it, you have to find oil in the first place. Continental shelves have some of the largest and least explored oil reserves in the world. With such huge potential, they've fallen under the gaze of oil companies. But hunting for oil at sea presents its own set of unique challenges. Geonodal Solutions has developed a patented technology that takes surveying to new depths. Their hydrographic surveying technique comprises a series of nodes that can create 3D images of the ocean floor and is faster and more cost-effective than traditional methods. The technology behind the company's success is a result of the work conducted at the Institute of Earth Physics, where research into ocean surveying started in the 90s.
Until recently, it was really only a bit of scientific fun. 5 years ago, even I didn't think this project was worth developing and marketing for the industry. But as new technology emerged, including new energy-saving microprocessors, new microcircuits, analog to digital converters, rapid wireless copying technology at speeds of up to 15 megabytes per second, that's much quicker than Wi-Fi, we can collect the data accumulated over a few days and transfer it in a matter of minutes, and then move the node to continue registration.
A successful test on the Black Sea has drawn the attention of some of Russia's leading oil companies. Before setting sail, the fully automated nodes are thoroughly prepped, checked and configured. Their power supply and electronics can also be controlled remotely. Once the ship reaches the required coordinates, they are cast over the side and plunged to the bottom of the seabed thanks to their disposable anchor. A satellite navigation system registers their exact location, and the nodes are capable of gathering accurate data up to 7 kilometers below the floor. The devices are deployed along a predetermined pattern at equal intervals to form a 2D grid. The size of the lattice can be as large or as small as necessary, while the node's direct contact with the seabed rules out any interference from weather or shipping traffic. An air cannon towed behind the ship releases powerful acoustic shock waves that travel deep into the Earth's crust and are picked up by the nodes.
Realistically, companies can drill down to 3, 4, or even 5 kilometers. That's the depth of most oil wells. Professional geologists are mostly interested in studying all the layers above the upper mantle. But our technology allows us to study the upper mantle as well.
Once the mapping is complete, the signal is given for the nodes to ditch their anchors and return to the surface. The anchors are completely environmentally friendly and decompose into quartz sand and water in just 4 weeks. When aboard, the devices transfer all the information wirelessly in less time than it takes to ready them for the next mission.
After that, we hand all of the data over to the geologists for interpretation. By using all kinds of interpretation software, they study the image and its attributes in many different ways. And the data they get from that can be used to locate drill sites and reservoirs.
Meanwhile, another Skolkovo residence, Rockflow Dynamics, just so happens to have developed a piece of software for simulating hydrocarbon fields. T-Navigator uses geological and seismic survey information to create 3D interactive models of existing and completely untapped reservoirs. The application lets engineers run dynamic reservoir simulations to find out how a well would behave, for example if water, steam, pressure or chemicals are introduced as part of the extraction process. This helps save both time and resources when finding the right drilling method and ensures the field is safe when operations eventually commence.
2013 is a very special year for us. For the first time in our history, overseas sales will exceed our sales in Russia. Our global partners include such well-known companies as the US-based Occidental Petroleum, Pioneer Natural Resources, the Japanese Jog Meg, and a Malaysian company. In fact, we're seeking a global presence now.
In the meantime, Russian oil majors such as Lukoil, Rosneft and Gazprom are already relying on the latest surveying and modelling technology to improve efficiency and safety, as well as keep our petrol tanks full. I'm also sure it'll come in handy with the technological challenges the shelf presents. The Open Innovations Forum, as the name would suggest, is the place to be if you have an innovation to showcase and like forums. So naturally, the Tech Up team had to get in on the action.
Focal point.
The Open Innovations Forum was held only for the second time at the start of November. The aim is to promote global cooperation in advanced technologies and innovation, as well as bring business, education and government representatives together. As well as the usual industry stalwarts, we saw a lot of new players looking to carve out their own niche. But as always, the proof is in the pudding. Augmented reality continued its shift from novelty to utility with this educational tool that promises to bring physics lessons to life. Transport was also a key theme, with composite materials making for faster racing cars and Skullcover leading the switch to green transportation with this folding electric car. While the award-winning reactable music synthesizer can make even the most tone-deaf of people into a music god. But if I learnt anything, lifelike humanoid robots still have a long way to go. One of the exhibits that really drew the crowds was this Viking all-terrain vehicle by Atom Impulse. Its superior off-road abilities have even caught the eye of the Russian government. With such a feast of innovations, don't be surprised if you see some of them crop up in future episodes of Technology Update. I'm afraid that's all for today's show. But with advances in oil extraction and surveying technology, and with the unveiling of novel modes of transport at the Open Innovations exhibition, I'm sure soon we'll find it much easier to enjoy the ride.